What's up everyone and welcome. In this episode, we are going to discuss new research showing the triad of Linux malware causing a drastic increase of attacks on Linux systems over the last year. Of course, I'm talking about the XorDDoS, Mirai, and Mozi malware. Linux powers most of today's cloud infrastructure, web servers, as well as powering mobile and IoT devices. It's popular because it offers scalability, security features, and a wide range of Linux distributions to support multiple hardware designs, and it gives great performance on just about any hardware. The scary increase of massive Linux attacks shows that there's increasingly nowhere to hide or feel safe from these nasty hackers. Let's see what else we can learn to protect ourselves and others from this research.
Oh, drat these computers. They're so naughty and so complex. I could pinch them.
Malware targeting Linux-based operating systems commonly deployed in Internet of Things devices have increased by 35% in 2021 compared to 2020, according to current CrowdStrike threat telemetry, with the top 3 malware families accounting for 22% of all Linux-based IoT malware in 2021. XorDDoS, Mirai, and Mozi are the most prevalent Linux-based malware families observed in 2021, with Mozi registering a significant tenfold increase in the number of in-the-wild samples in 2021 compared to 2020. The primary purpose of these malware families is to compromise vulnerable internet-connected devices, amass them into botnets, and use them to perform distributed denial-of-service attacks. With various Linux builds and distributions at the heart of cloud infrastructures, mobile and IoT, these malware families now present a massive opportunity for threat actors. Congratulations, you're doing a great job by wanting to learn about Linux targeted malware and by watching my episode about it. I appreciate your support. If you think I can improve on anything, or again, just want to say hi, don't forget to leave me a comment in the comment section below. And if you haven't already, why not subscribe to my channel and smash the bell to be notified when I upload new episodes where I give you insights into the newest important cybersecurity news stories like this one. With my insights, you can be better prepared to protect your company, your family, and yourself against these and other cyber attacks. So hit that subscribe button and let's continue learning about this story together. Analyzing the current Linux threat landscape, the XorDDoS, Mirai, and Mozi malware families and variants of them have emerged as the most prolific in 2021, accounting for over 22% of all IoT Linux targeting malware. Now let's talk about each one of these three, one after the other, to see exactly what we can learn from them. We start off with XorDDoS, which had a 123% increase in malware samples in 2021. XorDDoS is a Linux Trojan compiled for multiple Linux architectures, ranging from ARM to x86 and x64. Its name is derived from using XOR encryption in malware and network communication to the command and control infrastructure. When targeting IoT devices, the Trojan is known to use SSH brute forcing attacks to gain remote control on vulnerable devices. On Linux machines, some variants of XorDDoS show that its operators scan and search for Docker servers with the 2375 port open. This port offers an unencrypted Docker socket and remote root passwordless access to the host, which attackers can abuse to get root access to the machine. Next up in our triad is Mozi. It was 10 times more prevalent in 2021. Mozi is a peer-to-peer botnet network that utilizes the distributed hash table system, implementing its own extended DHT. The distributed and decentralized lookup mechanism provided by DHT enables Mozi to hide command and control communication behind a large amount of legitimate DHT traffic. The use of DHT is interesting because it allows Mozi to quickly grow a P2P network, and because it uses an extension over DHT, it's not correlated with normal traffic, so detecting the command and control communication becomes difficult. The botnet is able to enslave devices to launch distributed denial-of-service attacks, launch payloads, steal data, and execute system commands. If routers are infected, this could lead to man-in-the-middle attacks. Mozi infects systems by brute forcing SSH and telnet ports. It then blocks those ports so that it is not overwritten by other malicious actors or malware. To complete the triad of Linux targeting malware that exploded in 2021, you have to talk about Mirai, the common ancestor. Mirai malware has made a name for itself in the last few years, especially after its developer published Mirai source code. Similar to Mozi, Mirai abuses weak protocols and weak passwords such as telnet to compromise devices using brute forcing attacks. With multiple Mirai variants emerging since its source code became public, the Linux Trojan can be considered the common ancestor to many of today's Linux DDoS malware. While most variants add on to existing Mirai features or implement different communication protocols, at their core, they share the same Mirai DNA. So what can we learn? If you have Linux anywhere in your network, whether it's a personal PC or servers or IoT devices, then you must take some immediate steps to protect your environment and your data. Keeping your systems up to date, documenting your infrastructure, as well as frameworks used in software you may build or rely on, is one way to ensure that you stay on top of the scene. Education of family and employees is also imperative to mitigate any attacks happening through an unwitting user through, say, a phishing attack or social engineering. Implementing policies for things like passwords, web usage, device usage, and the like further help family and employees to protect environments from infection. You could also use a mostly off security policy for services like Telnet or SSH or RDP, where those services are not on by default. This reduces the attack surface since those ports or services will not be available or respond during an attacker's scan. Whatever service or technology or plan you use, it should definitely include an on-premise and off-site backup plan to protect you just in case something makes it through the cracks in your protection. With that, I say thanks again for watching. Don't forget to share and subscribe if you haven't already, and smash the bell if you haven't already, and I'll see you on the next episode. Take care.
Don't forget to ride. Farewell.